All right. Well, good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Harness. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we will be sure to send you a recording of this program via email shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions for our speakers today, we do want you to send those into that Q&A tab. Sending your questions to the Q&A just helps us keep track, and we've got plenty of time set aside at the end of our program to answer your questions. So if you send them into the Q&A, we'll have a better likelihood of seeing it, keeping up with it, and addressing it live. Additionally, we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So ways to become eligible for this giveaway are to send in chats, send in questions, or to fill out our post-webinar survey. That survey is attached in the handouts, but I'll also be posting a link in the chat toward the end of our session. So without any further ado, our topic today is implementing governance for chaos experiments with Harness ChaosGuard. I'm joined today by Ty Davis, Product Marketing Manager at Harness, and Uma Mukara, Head of Chaos Engineering at Harness. So Ty and Uma, thank you both so much for joining us today on Techstrong Learning. Ty, would you like to dive us right in?
Yeah, thank you so much, Cody. I appreciate it. Great introduction there. To mirror what Cody had said, today's chaos engineering, we're going to talk about achieving continuous resilience with Harness Chaos Engineering, as well as taking a look at ChaosGuard and the governance of chaos experiments. We did get a light intro there, but I am Ty Davis. I'm Director of Product Marketing at Harness here, focusing on feature effects and chaos engineering. And today we have Uma, who is the head of chaos engineering, and Uma is the co-founder and previous CEO of Chaos Native, which was acquired by Harness, which is the original creator of the cloud native computing foundation for Litmus Chaos, which is used by hundreds of leading organizations, ones like Intuit, Mercedes, NetApp, Red Hat, VMware. And it's a highly scalable and secure enterprise platform for chaos engineering, so part of the CNCF. So with that, I'm going to pass on to Uma here, but what I'm going to do first is to get this kicking and going off. I want Uma to dive in a little bit more about the history of Litmus Chaos and Harness Chaos Engineering. So Uma, go ahead and give us a little bit of background on both those.
Sure. Let me share my screen for that. All right. Thank you, Ty. Hi, everyone. Good morning. Good evening. So I'd like to talk a little bit about the history and the introduction to Harness Chaos Engine. The history is more on it's built on top of Litmus Chaos. It's built on top of Litmus Chaos, the open source leading chaos engineering tool that's hosted at CNCF as an incubating project. And I happen to be the co-creator along with another maintainer. It's used by thousands of users, hundreds of large organizations, pulling about 1 million Docker pulls in a month. That shows that this chaos engineering framework is in wide adoption with a robust open architecture. And this is the basis for the enterprise chaos engineering tool, Harness Chaos Engineering. Let me talk a little bit about where Harness Chaos Engineering is being used as a use case. Mostly a lot of financial services users use chaos engineering, and they would like to have enterprise chaos engineering tool set. And primarily, the reason why chaos engineering is used is for regulatory reasons, also to reduce the reliability losses. And another common use case that I see is diverting the DR investments into modernization through chaos experiment orchestration. So you can do chaos experiments as well as do this DR automation as well. And it's also a common need in highly scaled environments or performance test beds, where you're moving on to the new architectures and you're supposed to do scale and performance testing, and chaos testing definitely helps. And obviously, the other common use case for chaos engineering as well as for Harness chaos engineering target use case is the Kubernetes environment, where there's a need for the chaos testing as the architecture of Kubernetes demands it, where there are hundreds of microservices, and a lot of them are dynamic in nature, both in terms of coming and going up, as well as the frequency of the software getting refreshed. When you have such a dynamic environment, something is always moving, and you need to do the dependency testing of something happening, something wrong happening in one of the microservices. So these are the common use cases where Harness chaos engineering is becoming useful to reduce the overall reliability losses, and to increase or to improve the recovery times. So back to you, Ty. This is a bit of an intro, but I can show a little bit more of the tool later on.
Yeah, I know a little bit later on you talked about we're going to have a demo here, so that's going to be really cool to go inside the tool and see how it works. But in the meantime, why don't you cover what the top features of chaos engineering might be?
Sure. The top features of Harness Chaos Engineering. A lot of the common talk about chaos engineering, when you say, hey, what do you support as a chaos tool or a chaos product, people usually talk about, what chaos experiments or chaos faults that particular tool supports. While, I'm trying to set here the Harness Chaos Engineering tool as a framework to achieve the overall continuous resilience in the enterprises around the services that they offer. For that, the tool set is just one of the pillars. As you can see, that the way you can achieve the continuous resilience in the medium to longer term is by following this, having these four pillars. One of them is chaos faults. I'll talk about that. So Harness Chaos Engineering supports about 150 plus different types of faults, and we probably have the widest coverage in the market today. In terms of the cloud native faults, we support all sorts of chaos faults in the library, and including some of the advanced API chaos or database chaos. And in terms of the non-cloud native or the regular legacy workloads, we support again, a wide variety of them, including Windows and Linux, PCF, all cloud platforms, and VMware workloads as well. So this is how, as much as the fault library goes in, 150 different types of faults, and we also have a nice SDK if you want to write your own fault. And at the same time, as I said, that's just one of the faults, right? One of the pillars. And the other three pillars of Harness Chaos Engineering is about how easy it is for these chaos experiments to be integrated into the regular flow of either DevOps or on the SRE side. So you can integrate super easily with either CI/CD pipelines or APM. Um, or we also have a governing tool for the chaos orchestration, which is what the primary topic of this session. And there's another feature that I would like to mention here. The primary feature is how do you actually measure your chaos experimentation adoption in your organization. The typical metrics that people follow is about are you reducing the overall number of incidents, or are you recovering your systems faster? That's more of reliability metrics. In terms of chaos engineering metrics, you would like to see resilience scores of services and resilience coverage of services through chaos experiments. So I would like to summarize it as these four pillars are the top four features of chaos engineering, using which you can not only do just chaos testing, but you'll be able to achieve in a systematic way the entire path to continuous resilience.
Thanks, Yuma. So when we're looking at chaos engineering, what are some of the challenges that you see in the adoption of chaos engineering? And even if you want to talk about, why is it important that chaos, if we're going back to just the basics, why is it important that chaos engineering is implemented at an organization? Maybe someone that hasn't heard about it or they're somewhat familiar with it. What's the number one reason that you think somebody should be implementing chaos engineering, and then from there, talk about the challenges that come along with adoption of chaos engineering?
Well, so yeah, for those who want to know about chaos engineering, what is it and why is it? Chaos engineering is a mode of testing or a method where you use controlled faults as a way to test if the system is resilient against that fault, and then you try to automate this process, over a period of time, thereby you're trying to verify more and more resilient ways in which the system is operating. At the same time, if there are any weaknesses against which the system is suffering the reliability, when finding so, you would be more proactive in trying to fix those issues, thereby increasing the reliability, right? So it's kind of like a dependency failure testing. There are a lot of components that depend on each other, and something small can go wrong in one of the systems, and that might lead to a bigger outage, right? So instead of waiting for such chances, you proactively test them in potentially in the lower environments, and when you have a mature practice, you start testing in a limited way in production as well. So that's chaos testing at large. That's what it is. And why is it required? Is obviously you want to reduce the reliability related losses, right? And what are those losses in your business that are reliability related? Potentially the outages, right? When outage happen, end user experience will take a hit, as well as there may be a potential penalty related financial losses. And there are some indirect regulatory related losses that can come in as well. And also a lot of your developers and SREs will go back into this incident management process. That usually, if the incidents are frequent, a lot of this developer time is going back into debugging, bringing back the services, and sometimes it could be very, very costly, right? So you would want to reduce this reliability losses, and typically your functional testing may not cover a lot of these scenarios. So you would introduce chaos engineering to do that. So that's about managing reliability loss reduction through chaos engineering and improving the resilience of the overall system. I'll go into how you would be able to do that when I show the tool itself. But Ty, you asked me what are the typical challenges in adopting chaos engineering. So let me touch upon that here. The challenges are so if you look at a chaos engineering adoption cycle, right? Harness recommends this chaos maturity model to be, studied and followed upon in the adoption of overall chaos engineering practice implementation. Typically, you can see that some teams starting at level one, some chaos testing on one application within one team. That's kind of the introduction of chaos culture into one of the teams or one of the applications in the organization, and then going to the next level where you try to automate these experiments into your pipelines or through your other DevOps practices, and then try to scale them to more chaos experiments, to more services, to more teams. And finally, when you reach the expert level, some chaos testing is happening all the time without somebody specifically running a chaos experiment. So everybody assumes that there is some random chaos being injected into the system, and your resilience is being verified all the time, right? This is kind of the adoption cycle, and it could take from anywhere from 1 year to 3 years or even more by the time you reach from level 1 to level 4, right? So this is the adoption cycle. So when it comes to the challenges, right, I can categorize some of the challenges into following categories, right? So first is, typically securing the right stakeholders itself could be a problem, right? So that could be a problem for adopting chaos engineering in the right way in the organization. So what I mean is, somebody wants to run chaos experimentation, but they may not be authorized to do chaos testing while bringing down some availability zones, or they may not have the budget to prepare the overall running of this chaos experimentations. So it's very important that there is a high level top down approach to this entire chaos engineering practice, right? So that's one of the challenges that we see. And then also, where do you actually start running this chaos testing, right? Initial environment, would you start in the production or non-production or QA environments? And when you're running, do you have the required permissions or not? So typically, the most of the chaos engineering practices are successful when you start in the lower environment and then move towards the production environment, right? That's because you have low barrier and getting permissions are easy, right? And the third challenge that I can think about is when you have the right stakeholder and stakeholders supporting your chaos engineering practice. And also, when you started on the lower environments, you have all the permissions. The biggest challenge that you encounter while moving from level 1 to level 3 or level 4 is how easy it is for you to scale in terms of how do you write more chaos experiments, what chaos experiments do you need to write, and also having the right governance, right? Many times if you implement chaos practice in an ad hoc way, some unwanted side effects may come, and then there are some negative outcomes, somebody losing the test setups, somebody losing a lot of productivity around it. So you would like to generally have a good governance around the chaos orchestration, and that's a lack of it is typically a big challenge. So back to you, Ty.
Yeah, so a question came through for you, which is how can smaller organizations perform a chaos experience while having, I think, insufficient resources for establishing guardrails, monitoring, governance, etc. So is there a leaner process SMBs can follow?
Yes, good question. Chaos tools have evolved a lot in the last 3 to 4 years, right? For example, Harness Chaos Engineering a couple of years versus now provides even all the enterprise features to start automatically creating chaos experiments, setting up connectors for most of your APM systems. And when you don't have an APM system, trying to provide Prometheus as a way to start off, monitoring in the lower systems, and then automatically creating guardrails. So there are chaos engineering tools are more mature now, and it has certainly become easy for you to get started in an advanced way, even though you are a small setup with less experience in chaos engineering. Definitely, you have much better tools. Yeah, and that's one of the reasons why we are here to talk about that. How easy it is to set these things up.
Appreciate it. So another one come through. Is it difficult to determine how the outcome was achieved when other factors outside of our control have influenced in results? So, or which can make it difficult to reproduce effective results. That is the main reason for hard to get buy-in from management. What is the best approach to overcome that?
Again, good question. One of the advocated practice around chaos engineering as a benefit of chaos engineering is, hey, if you practice chaos engineering, your outages should reduce, right? Or your recovery time should improve. And it's very, very difficult to do that in short time, to go back to your management and say that I'm doing chaos experimentation. Here is how the number of incidents have reduced. It's very, very difficult and may not be possible in the short term. So the right way to do it is to tell them that what is the percentage of your resilience coverage that you have encountered in a given set of time. Without chaos engineering, everything is unknown, right? And now with some chaos engineering, you have established what is resilient, right? Certain use cases. And whenever you see that there are less resilient systems, you go and actually start improving the recovery processes, right? So the fire drills, game days, automated chaos experimentation will teach the developers, a better knowledge about your systems when something goes wrong, and with that knowledge, you start improving the recovery times. So the right way to go back to your management on the progress of chaos experimentation or the advantage of chaos experimentation is to tell them that recovery times are improved. Much of the recovery process is being automated, as well as the percentage of known resilience is increasing. So that's a better way to uh, gauge the system so resilient, and the effort that you're putting is measurable. It's something similar to, you have a lot of functional testing teams, and you're releasing the product by showing that the system is functional, right? And when you release it, the systems are functional, right? And very, very similar. It's not that you have to prove the reduction in the faults, but reliability losses are also related to developer productivity losses. When you have reduced recovery times, your developer productivity is increasing, and you can use that time to go and do better product building, etc., etc. So that's really one of the ways in which you can look at the benefits or results of chaos engineering. Yeah.
Awesome. So we're here to talk about chaos governance and implementing governance for chaos experiments. Can you talk about the RBUX, and then let's possibly go into the demo?
Sure. Let me talk about the governance in Harness Chaos Engineering. And, without, before going there, let me just talk about the need for chaos governance in the chaos orchestration by talking about what happens if you don't have governance, right? So without governance, almost everything is ad hoc. Your chaos practices, a lot of chaos experiments are running, and anytime things can go wrong, right? So that's like unknown. And there could be a temporary loss of access to your test environments because somebody deleted a node or a node pool or set of nodes. That could be very costly. And when you do some a high blast radius test cases, chaos tests related to databases, right? So sometimes the data becomes unrecoverable, and especially you know that there are single point of values around data, but somebody goes and removes such volumes, thinking that systems are resilient, right? So that could prove very, very costly. And also, when you do some chaos testing in production, unintentionally you could cause outages, and that could be a breach of some compliance and legal requirements that you are bringing down the system without knowing, notifying your customers, like a maintenance period and all. So you want to be careful about the side effects of chaos orchestration. While it adds a lot of value by bringing down the recovery times and effective outages, building better resilient systems, you want to be wary of the side effects it could cause, while intentional or unintentional. So that's where the governance is needed. And the governance in um, Harness Chaos is of two types. One is Harness platform itself provides some role-based access controls, and also there is a deep access control list or capability called ChaosGuard, right? And if you want to talk about these two different features or areas of governance, platform Orbax is more about who can create something, right? Or who can just view something. So, for example, who can create chaos experiments or just view the chaos experiments that are already created, who can execute them. And similarly, there's a concept of chaos hubs, who can add new chaos hub, who can bring in the new chaos target onto the control plane, and who can run a game day, and who can set up deeper ACLs. This is like creation time controls that are supported through the platform, Harness platform or BACS. And this is one level of governance. The other level of governance, which is the deep governance, is there are a lot of chaos experiments that are created and someone is trying to execute, right? Either manually through automation, or through webhooks. Somehow this chaos execution, chaos experiments are getting triggered, and the governance that is controlled here is around who can execute, right? A particular person either can execute or cannot execute, and the time during which time on what specific target. So this is, you come in as a governing body outside or on top of the chaos experiments, and set some rules and conditions, so that when a chaos experiment is executed, these rules and conditions are enforced. And similarly, when chaos experiment is sent to a particular target, there are certain service accounts which you don't want to execute as, because they're very powerful, have a lot of permissions. So you may want to be wary of that. So this is almost like setting up filter firewall rules in a network where you allow only very safe packets inside. Similarly, you allow whatever you think are the safe chaos experiments. You allow them. Everything else gets blocked, right? And this is how chaos guard works. You define overall a set of rules, just like firewall filter rules, and within each rule there are set of conditions. When any of the blocking condition is met, the chaos experiment gets stopped, right? So that's like a very common logic. And then I can go back into the product and show the demo of chaos guard itself. So before I do that, I can see if there are any questions um, on the chat here.
Yeah, so I'll read them off to you if you want me to. How can we do chaos testing if it involves bringing down an availability zone on a public cloud, for example, AWS?
Okay. There are a few ways in which availability zone based chaos testing can happen. One of them is, it always consists of multiple nodes. So you could filter out the nodes and temporarily take down the nodes through the label. For example, if the availability zone has 10 nodes where there are applications that are running on them or is concerned, so you can bring them down a part or fully. That's one method, directly going after the nodes. The second method is through the load balancers that control this availability zones, right? So you can cut down access to this load balancers through the security groups, and similarly the resources inside availability zone or control through the security group access. So I'll show in the product. Maybe this is a good segue to get into the product and show what are the faults that are available to do some availability zone related failure testing. So this is the product, Harness Chaos Engineering. It's one of the many capabilities or modules on the Harness platform, which is available both as a SaaS option or as well as on-prem. The capabilities of both the systems are exactly same. So this chaos module, you can see a lot of chaos experiments here. Let me go to the chaos hubs, which is a set of experiment templates or set of chaos faults, right? So it's categorized into different types of chaos faults, as categorized as clouds or target systems. So here you see on AWS we have some availability zone down based on either cluster load balancer or AZ or NLB. You can also do network load balancers. You can also go back around EC2 VM stop, right? So for example, EC2 stop by ID or by tag. You can tag all of them together or many of them, so that a majority of your availability zone VMs are down, right? So that's one of the ways in which you can achieve the AZ failure testing, right? Um, any other question I can take before I talk through the chaos guard itself, Ty?
I think the one question that's out there is what you're about to go into, which is highlighting some of the key features, capabilities of Chaos Guard that differentiate it from traditional chaos engineering tools.
Okay. Yeah, so Chaos Guard in Harness C definitely is kind of very advanced, where you have um, full control on who can do what chaos experiment on which targets, right? So before I get into Chaos Guard, let me go into the RBACs itself. So for the role-based access control capabilities, you would like to understand a few more features of Harness Chaos Engineering. So here, the role-based access controls for chaos are around who can create chaos infrastructure, right? And this is all on a per role, which can be assigned to people, the teams inside a project, and similarly, who can run chaos game days, who can create or edit, or just they have view access. You can pull in the experiments from the chaos hub, or who can create chaos experiments or just view them in the project. And similarly, the chaos guard itself is a feature where somebody should be able to create new rules and conditions or just view them, right? So if they don't have any access, they don't even see chaos guard, but when they execute chaos experiment, they are just implemented, right, or they're enforced. So these are the RBACs available on the platform. And let me talk through some of this, what is chaos infrastructure and what is the chaos experiment in the product itself. So you have environments here which are categorized or production, non-production, UAT, etc. These are logical environments, but within the environments you will have your actual targets or target clusters or target hosts are connected, right? There are multiple types of chaos infrastructures that are supported, Kubernetes, Windows, or Linux. where the Kubernetes chaos infrastructures can be used to target not only chaos infrastructure, not only Kubernetes resources, but also the AWS, GCP, Azure, or you may be having some VMware systems in the same environment. So all these targets can be approached or can be acted upon via chaos through this infrastructure, right? So one of the main things that you would do in the beginning is to bring in a target system into the control plane. So who can bring in that? Who can add that, right? So that is one of the RBACs. And then once you have such environments come in into the system here, control plane, then you start creating chaos experiments, right? The chaos experiment, you can actually see here what is the target infrastructure, and then you set up the faults, etc. So who can create that chaos experiment is another thing. And when you have chaos hubs, you can create new chaos hubs and maintain your chaos experiment golden copies in that and share them with other teams. So who can create those chaos hubs? That's another governance roles. And then you also have chaos game days. You can create new chaos game days by pulling in the chaos experiments from the enterprise chaos hub or your own chaos hub. So who can create and run this game days is another type of RBAC, right? So these are the general RBACs, right? And a chaos experiment in Harness Chaos Engineering will have the following um, pattern, right? So, for example, if you look at one of the chaos experiment here, it can have multiple chaos faults that are pulled in from your own chaos hub or enterprise chaos hub, and you can run them in parallel or put them in sequence, and then overall, when it is completed, you will get a resilience score, right? So let me pick up some of the other experiments where this chaos experiment was run many times and there's varying results of resilience score, right? So the resilience score depicts how resilient your target system that underwent chaos testing against the faults that are given, right? So how you measure the resilience score is by counting the successful checkpoints or successful probes. So when there are about 4 probes that you checked during the chaos experimentation, if 3 of them have passed, then you get 75% as a resilience score. So this is how the chaos experimentation happens, and then is kind of viewed in Harness Chaos Engineering. But now we are talking about governance, right? In this session. So as you can see that there's a step here within this execution model called evaluate rules. So any experiment that is run, you can go and uh, see that the first thing that happens is evaluation of rules. And evaluation of rules, there are no rules that are matching, so it just went through. But if there are some rules that are preventing, then the experiment gets blocked. So let me just show first an example of blocking experiment, right? So I have an nginx experiment that's supposed to do some network loss on nginx, and I have a chaos guard rule um, that actually two rules that blocks the network faults and also blocks the nginx app. No fault should be run on nginx. So I can go and see that in this rule, this applies to a set of users called demo user group, right? And demo user group are this set of users. So if any of them are running, don't let them run during this time between the March 12th and April 29th. Anytime if they run certain experiments don't allow. And what are these experiments is you can go and see this is like um, a YAML view of it. I can show a condition that shows a detailed visual view. This is the one. right? So it's basically this condition shows that pod network faults are not allowed on this cluster and this application. So basically, you don't want a certain group of users to run network related faults on this application running on this cluster. That's exactly what is configured. And let me run that experiment, right? The chaos guard rule itself is enabled. And if I go and run that experiment, nginx, right? So um, I try to run this, it gets blocked, right? That's because one of them is matching, and this got failed, and node blocks are allowed. This also matched, but there's no node fault here because there are only network loss experiment fault that's getting executed within this experiment. So this condition is passed, but this other condition is failed in the rule, so it gets blocked. Now, if I go back and disable that rule, that means I go and enable, allow this nginx app, or I don't care about nginx chaos experiments on this. So the same experiment, if I try to run again, um, that evaluation rule should pass, and then it goes on to the actual experimentation, right? So that's a simple demonstration of how you could control, and then control the experiment execution. So let me show the conditions itself, right? um, if I look at these rules, there are users, and there is times, and you can add more conditions into that, right? So you can, there are existing conditions here, you can put any of them, and at least if one deny condition is matched, then the execution is kind of blocked, right? So this is one condition that's put. You can put more conditions, right? And when you create these conditions, we also support some gen AI capability, yeah, right? So sometimes these are difficult to write, or which ones are, if you are automating, you want it usable. So we have Harness ada, right? AI developer assistant, where you can sample ones. Some more things are provided here. So you could ask Harness ada to create and apply ML, and then the condition gets created, right? So there is a Harness ada help for you to create new conditions. Then you can pull in these conditions into the rules and then go after that. So basically, to summarize, you have chaos guard, which allows you to define rules and conditions to the most granular level, where you can see conditions like what faults you can use the regex. We have 150 different types of faults. You can use regular expressions to select them, and you can also choose on what target clusters, and which target application, and running as with which service account, right? So these are the kind of deep chaos ACLs that you have to control the governance. So that's a bit of a small demo around chaos guard. Hopefully that was helpful. Back to you, Ty.
Thanks, Uma. And if anyone has any questions, start putting them in now so we can answer some of those before we end today. But there is a question, more of looking for your suggestion or advice in terms of, are there any tools to help gauge cost increases to support resilience requirements that can be used to assist in making architecture decisions based on a budget that accommodates an application's SLA expectation?
Yes, cost. Yeah, there is an ROI calculator that Harness provides itself. So I can just take you through that. So you can fill in what are the SLO related incidents that are in your system in the company, and you can approximately put in what are the services through which you would want to implement some chaos testing, and you get the detailed report when you fill in how you arrived at. So this is typically will be the a business case put up. You go to the management and say that, hey, here is what we invest, and here is how you're reducing the losses. So typically the business case for investing in chaos engineering is to reduce the ongoing losses, right? If there are no incidents, then everything is resilient, right? So if there are incidents, there are some SLAs that you're breaching, so there are already some losses, and how do you reduce that losses, right? The losses are categorized into two types. One is business related losses, and the other one is developer related losses. A lot of your developers are actually trying to recover the systems, wasting time rather than doing the important development work, right? So you can use this ROI, and when you fill up the details, you also get a full report, in detail. Hopefully that is helpful.
Thank you. So to close us out, if you can give some best practices around ChaosGuard and any that you'd recommend while using ChaosGuard.
Sure. So first of all, yeah, I recommend having governance implemented, right? So don't venture into deep chaos orchestration or scale your chaos practice without proper RBACs or governance rules. And when you have this have certain number of people, at least few, to have the ability to set up these rules. Sometimes you want to deny certain execution, and that person with that role may not be available. So it's good to have few members as chaos guard admins, and then also try to create chaos rules that are time bound, right? So generally allow the falls only during certain times or deny them certain times, right? So you typically have maintenance period, so you can go ahead and say that block all types of falls on all targets during this time by any user, right? So you're taking care of that maintenance windows, right? Or this blackout periods, where certain freezes are there, no code change or code changes are allowed or upgrades are allowed as business rules. Obviously, chaos testing also should not be allowed. Who knows? Somebody has automated some chaos testing to be triggered based on certain time or based on certain webhook. So you don't know when an chaos testing is coming onto your system. So when it goes through the control plane, it's good to put those times. In this time, I'm not allowing this chaos rules. And also the other best practice is to, by denying all chaos testing on production clusters, right? And once you deny, and then start creating the allow rules, right? Only these people can run chaos experiments on production clusters. So at least you have some responsibility, tagged to certain people who are running chaos experiments in production, right? So that's these are some of the obvious best practices, but some of this may be applicable or may not be applicable based on where you're doing this chaos testing. But I can think of this as some of the good practices.
Appreciate it, Uma. Last call for any other questions if you want to put them in the chat there. In the meantime, want to let you know that you can try Harness Chaos Engineering for free. You get all the enterprise capabilities as part of that. You may probably even get, if you want to do a demo or POV, you get Uma, the man himself, in helping out and helping you identify that. what you want to get done there. And so with that, I don't think we have any more questions, but really want to say thank you for coming in and listening about Harness Chaos Engineering today. I'm going to pass it off to Cody here. And again, thank you, Uma, for taking the time to do this. It's midnight where he is right now, and he has a flight to catch in 5 hours, so he needs to go to bed right after this.
Thank you. It's a pleasure being here.
All right, Uma. Yeah, with knowing that, thank you so much for joining us today. Ty, thank you as well. But to the two of you, thank you so much for joining us today on Techstrong Learning. It has been such a pleasure hearing from you over the past hour, and hopefully our audience has a whole lot to take away from here. Ty did throw a couple of links in the chat as we were wrapping things up here today. Those can also be found now in the handout section, so do grab those while you're here with us. We would love for you to grab that before they're done. A couple of other final reminders. Today's session was recorded, and you will be receiving an email with a link to access the recording on demand, but you'll also find this living on the DevOps website. So just visit devops.com/webinars, and you'll find it in the on-demand section. We will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you all for your chats and your questions. If you'd still like to become eligible, there is a link in the handouts to our survey, and you can also find a link at the bottom of the chat. So either one of those will take you to our survey. Filling that out will make you eligible for our giveaway, but most importantly, we do want to hear your feedback and your thoughts about our program today. I'd like to thank Harness for sponsoring today's session. And to our audience, thank you so much for spending your time here with us. We appreciate you, and we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Uma and Ty, thank you both so much.
Thank you.